the Zen koan because it's, well, a koan is a riddle that sort of shocks you into some new realization. The classic one is the sound of one hand clapping. So there's a strange thing about this problem. It's sort of shocking in the sense, in its symmetry. Notice the tops. We have y minus 3, and then it reversed over here as 3 minus y. Similarly, the bottoms are the same binomial, except they are reversed. I want to show you a general property of numbers that for some reason doesn't get discussed in algebra books, and this is a shame. Essentially, what I want to show you here is we take any two numbers and we subtract them, and that is not going to be equal to those same two numbers subtracted in a different order. In this case, we have 5 is equal to negative 5. If you take any two numbers, this is a situation that develops. They're not equal, but they're opposites, and we can use that to our advantage. For instance, I know that a minus b will not equal b minus a. However, I know that a minus b will equal the opposite of b minus a. So, if you look at these two things, if you look at this binomial and this binomial with the sign in front, they are identical, and we can replace one with the other. And just in case you're not certain of this, let's just take two other numbers. I said that 6 minus 10, there's a binomial, is equal to the opposite of 10 minus 6. Okay, so let's just crunch this out to make sure this is true. Does negative 4 equal the opposite of 4? Yeah, sure it does. This absolutely makes good sense. So, going back to this equality here, we can replace a minus b with this, or alternatively, we can replace this with a minus b. So, in terms of my Zen koan, I like the order I have here. I like the unknown coming first. And also, I recognize this is a difference of two squares, but I'm not going to crack it just yet. Let's leave it the way it is, y squared minus 25. And now I have a minus sign. And, okay, now this situation here, this can be replaced, this, think of it as this, can be replaced by this. So I can replace 25 minus y squared by the quantity, the opposite of y squared minus 25. And I can also do that with the 3 minus y upstairs. All I have to do is put a minus sign and reverse the subtraction. And these two are exactly equal. Now, the minus signs can be thought of as multiplication by negative 1, and since we have all multiplication in the top and the bottom, they cancel. Let's do a little bit of cleaning up here. We have y minus 3 on the top minus the quantity y minus 3. Still we have two fractions whose denominator is the same. And when the denominators are the same, you go ahead and simply do the multiplication, or excuse me, the arithmetic. So we're going to have y minus 3 minus y minus 3 on top, and y squared minus 25 on the bottom. Well, clearly, a y minus 3 minus a y minus 3, these are the same numbers, and when you subtract the same numbers from each other, you get 0. So we have 0 over y squared minus 25, and you know, I've got a lot of students who fall down right here. They say that this is undefined. And of course, it would be undefined if the 0 was in the bottom, but it's not. And so what we say here is that the answer is 0. 0 divided by anything is 0. And so there's our answer. And as a check, what this means is that if we put any value in up here, it's going to evaluate to 0. Let's run that little check right here. Let's let y equal, how about 4? So we have 4 minus 3 on top, and then we have 4 squared, which is 16 minus 25 on the bottom. And we're going to subtract 3 minus 4 on the top, and then 25 minus 4 squared, or 16 on the bottom. And we claim that this is going to go naturally to 0. Okay, this is 4 minus 3 on the top, which is 1. And I'm not going to do, well, I have 16. This is actually 16 minus 25, which is a negative 9. And then I'm subtracting. On top we have a negative 1, and on the bottom we have a positive 9. Okay, this over here is just a negative 1/9. I'll write the minus sign up front, up top. And here I am subtracting a negative 1/9, which is the same as adding a positive 1/9. And I think you can see that this does indeed go to 0, and it checks. And this will be true for any y value that's legit. The only y values that aren't legit are things that make the denominator 0, like 5 in this case, because that would be 25 minus 25, or negative 5, because that would be 25 minus 5 squared, or 25, which would give you 0. So for any value of y that's not 5 or negative 5, this thing right here will indeed evaluate to 0. Okay, I hope that helps, and good luck with Chapter 6.